Welcome once again to today's physics class. In today's class, we are going to solve question number 4 on this projectile motion. So we have the question here. It says the horizontal component of the initial speed of a particle projected at 30 degrees to the horizontal is 50 meters per second. If the acceleration of free fall due to gravity is 10 meters per second square, determine its number 1, initial speed, B, speed at the maximum height reached. This question is kind of confusing anyway, but it's very, very easy. Before we solve this question, if today is your first time of coming across my page, do well to like and follow, and also share for other students to benefit. Now, first of all, let us draw the diagram. We are told that the particle is projected at an angle, which means at an angle 30 degrees projected before landing, okay? Projected at an angle with initial speed. We don't know the speed. An angle, what? 30 degrees with the horizontal. And remember, for this projection, this type of projection with an angle of inclination, we will have the vertical velocity, which is uy, then the horizontal velocity, which is ux. And now, remember that when you resolve the both of them horizontally, this is your uy, this is equal to u sine theta, because it is projected at an angle, theta here, and here will give us ux, which is equal to what? U cos theta. Now, we are given that what ux here is equal to 50. What they want us to calculate is this u, which is this velocity with which the object is projected. Now, from here, let's first of all get for a simple way, just put your 50 equal to u cos 30 degrees, because theta here is equal to what? 30 degrees. So just put u cos 30 degrees. Remember, your u now becomes 50 over cos 30 degrees. What is cos 30? I think cos 30 should be, that's 50 over 0.8660. Now let us grab our calculator and solve that. U will give us equal to 57.7 meters per second. So that is the velocity with which the object was projected. That is the initial velocity. Now, we want to get the velocity at the maximum height. Now, remember, at this maximum height here, when an object gets to this point, what happens is that at this point here, we only have the horizontal velocity, which is this ux. Here, the final velocity, vy, is equal to 0. Now, since we are now looking for the resultant velocity here, we want the resultant velocity of the both in initial velocity here, which is the horizontal and vertical components. So in that case, the velocity which we are required to find out at this maximum height is the resultant velocity of, we have v x squared plus v y squared. Okay. I mean, at this point, v of x is equal to what? U of x. Sorry for that. Not v of y. V of y at the maximum height is always 0. Okay. Now, at this point now, we have the final velocity of the horizontal component is equal to the initial velocity of the what? The same horizontal component. Now, for us to get the velocity, will be the resultant of the horizontal velocity, then of the final velocity, okay? Horizontal final velocity, and what? The horizontal of this, or the vertical velocity. And at that point, this one is 0. So we now have what? V equal to square root of, what is this one? Is what? 50 squared plus 0. Now, we have V 2500. What we just need to do, since here becomes square root of 50 squared. So this square and this square can go. So your V is equal to 50 meters per second. So that is the answer. At that point, remember, at this point here, v of y is equal to 0, okay? V of y here at the maximum height, the final velocity is always what? 0 along the vertical component. Now, for the horizontal component here, the final velocity is also equal to the initial velocity. That is where we have Vx equal to what? Ux. That is what we are going to use to calculate this. If you find this video lesson interesting, help us to share this post and do well to like and comment. Bye.